There are three variations that we will get exposed to in the syllabus. The first being the limit exists and it's equal to the value of the limit. So we are taking up a function x square and we are approaching the value of 2. So let's do that. So with this simulation, let's see what's the closest we can get. So as in when we get closer and closer, so we can see that we approached it from the left hand side because the x value is 1.98. That is, we are approaching from the value which is less than 2. So it has to be left hand side limit. And the output is 3.92. Let's add that to our data. Now let's approach from the other end. And we have this to be, okay, I can still manage a bit closer. Oh, this is the maximum. I can do better, but anyways, 4.25. If we reduce or if we approach it a lot closer, they will be equal, right? So you guys have to consider that because of my limitation over here. So I don't want to waste your time doing that, trying to get closer and closer. So you guys can imagine that yes, we'll get a lot better answer as when we approach and they are equal. F of 2, your traditional value wherein we substitute and all of that, 2 square, which is equal to 4. So in all of this, what is that we see? That the function's value is equal to the limit's value, right? So this is also equal to limit of f of x as x tends to 2 plus, and this is equal to f of 2 itself. So the overall conclusion is that the limit exists, right? Now, limit exists but not equal to the value at the limit, or let me just explain it rather than reading the heading. So we are approaching the value of 2. Remember that, keep that in mind. So we are at 0. So we are approaching from the left hand side clearly because all these values are less than 2. So let me zoom in to get a better picture. So clearly it's less than 2, and yeah, that's the closest, 1.9, and we have it to be 3.9 from the left hand side. From the right hand side, that's the closest and it's equal to 4.10. And at f of 2 what happens? See, let's substitute that over there. 2 square minus 4, which is equal to 0. 2 minus 2, which is equal to 0. So 0 by 0 is not defined. So we have this to be not defined basically. So what can we conclude now? It's not actually, these two values are not actually equal to the value at the function. Here limit x tends to f of x, x tends to 2 minus, it's equal to limit x tends to f of x as x tends to 2 plus. They're equal. Right, but they're not equal to f of 2 itself. Even in this case, we can come to a conclusion that limit, it exists. Okay, and the next case being this. Let me not read the heading. Let's do this. So in the last case, the limit exists even though it was not equal to the actual value at that point. Now let's approach it from the left hand side. So we have seen this actually before. So we have it from the left hand side as the x value is negative and the output is 1 itself. So whatever we do, it will be 1 because the function is defined that way. If I approach from the right hand side, whatever we do, however close we get from the right hand side, it is equal to 2 itself. Remember, we are approaching 0. And at 0, what is happening? At 0, the output is 1. So we have a definite value. In this case, we have the following. We have the function, one of the values, one of the limits. It's equal to the actual value. So both of them are equal. But they're not equal to the other limit. They're not equal to the other limit. So in this case, what should we conclude? Limit does not exist. Okay guys, last example. Let me resize this and let me zoom in. So as when we approach from the left hand side, we have it to be minus 2.1. So minus 2.1, right? If you approach it from the right hand side, we are approaching 0, remember. The closest as of now I can get is 2.3. Doesn't matter, plus 2.3. Clearly they are way off. Even if you approximate, nothing will happen. And at 0, we have it to be 0 itself, right? And overall, what can we conclude? Limit x tends to 0 minus f of x. It's clearly not equal to limit x tends to 0 plus, and all of them are not equal to f of 0, even though the value exists, and overall they are not equal to each other. Here too the conclusion is the limit does not exist. Limit does not exist. So with all of these different cases, we can generalize the following. And this is what you guys have to remember. The existence of a limit at a specific value depends on the right hand and the left hand limits only, not on the actual value of the function at that point. If both the right hand limit and the left hand limit approaches the same value as the variable gets closer to the desired point, then the limit exists. So this is what you guys have to remember. And yes, you guys have to write all of this. It's part of your syllabus.